3/2. That's one potential answer. And then I have principal inverse tangent of 3/2 plus a pi, and then plus a 2 pi, plus a 3 pi, plus a 4 pi, all the way down. You could do pi k, but the pi k thing might mean there's some negative answers, because that usually means both ways infinite, and you told me that. So I'm not too worried. This is not the final answer. So right now I'm really not interested in listing all this out anyway. I'm going to keep it here, because I just want to know for myself. That's what I'm talking about. This is just for myself, not for the final answer yet. Another critical number I need to know about when you're talking about speeding up, slowing down is the acceleration. The acceleration function based on sines and cosines is never undefined, because sine and cosine are never undefined, but it can equal 0. And it will equal 0 if negative 2 cosine t is equal to 3 sine t. Or in other words, sine over cosine is negative 2/3. So I'm now looking at inverse tangent of negative 2/3. So anytime the time can be calculated by doing inverse tangent of negative 2/3, that's a whole other set of critical numbers I have to care about. So kind of here's where I'm at. I have the tangent of t equals 3/2. That's one of the sets of infinite numbers from the velocity being 0. And I have also a whole bunch of situations where the acceleration is 0. And those all happen when tangent of the t equals negative 2/3. Right now you might be asking yourself, hey self, why did he do the inverse tangent here and he's doing regular tangent here? It's because inverse tangent is hard to do. Regular tangent is usually easier to do. Regular tangent makes you think, let me draw a picture. I'm trying to figure out what the heck's going on here. I'm going to try to draw a picture where the tangent of the triangle is 3/2. Here is said picture. Pythagorean theorem, 4, 9, should give me a square root of 13. So this is one angle that represents a time, where that time gives me a velocity of 0. Visually, that time is right here. But there's another time, and there's another time. So there's a whole bunch of times that are such that the tangent of those times is 3/2, forcing the velocity to be 0. And there's a whole nother infinite set of times based on a triangle down here, because it turns out negative 3 and negative 2, that's a triangle where the tangent is also 3/2. Turns out the radius, Pythagorean theorem, still is square root of 13. But it gives me a whole nother set of times. There's this one, there's this one, and there's this one. All of those give me a velocity of 0. So it's an infinite number for here, infinite number here. You've seen me do this before, but it's been a while, so I thought I'd kind of slow it down a little bit. What I can't use is this or this, because you told me time has to be positive. Okay, over here, here's all the places where the acceleration is 0. It happens when the tangent of a triangle happens to be opposite over adjacent, negative 2/3. Also could happen here where the opposite over the adjacent is negative 2/3. 4 plus 9 once again is square root of 13. So they're kind of related to each other, but they are different triangles. Okay, so now I have all the times where the velocity is 0, I have all the times where the acceleration is 0, and I forgot what the question was.
When is the speed the greatest, and when is the mass speed not?
Well, it's really hard on periodic functions to say when is the speed the greatest, because you told me time is going off to infinity. So I'm thinking there's going to be a whole lot of times where the speed is the greatest. So this is kind of a pain. You didn't say the velocity was the greatest, did you? You said speed is the greatest. So if I'm running straight ahead at 2 miles an hour, which is my top speed, by the way, or if I'm backing up as fast as I can at 2 miles per hour, they're different velocities, positive 2, negative 2, but they have the same speed. So if you had your curve of the velocity function, there's the minimum velocity and there's a maximum velocity. But both of those would have the same speed. My max velocity going forward is 2 meters per second. My maximum velocity going backwards is negative 2 meters per second, but that's the same speed of 2, right? So I'm thinking if I wanted to find out when is the velocity the biggest, it's going to be any time the derivative of velocity is 0. If this is your velocity curve and you want to find the top spot, the velocity rate, the slope is 0. You want to find the bottom spot, the slope is 0. So that's anytime acceleration is 0. So this, and that, and then that one too, as well as this, and this, are all the places where the speed is the greatest. So I think I'm going to make my answer of when is the speed the greatest as principal inverse tangent of negative 2/3, because that's when the acceleration is 0. Here's another way to think about it. People like to think of, if you accelerate your car, you're speeding up until you stop accelerating. That's your max speed. So that would be when your speed is the greatest. Another way to think about it, when the acceleration is 0, you're no longer changing your speed. Anyway, acceleration is 0 here. Now, inverse tangent negative 2/3. Principal inverse tangent, if you recall from earlier this year, gives me that. I can't use that as an answer. That's negative. So I have to add a pi. That's the first time the speed is the greatest. There is another time where the speed is the greatest. It would look like this. And then there's more. If I did inverse tangent of negative 2/3 plus pi k, it's okay. That is an answer as long as k is greater than or equal to 0. Nope, greater than 0. Which is a little too difficult for what I would do on the test. I don't mind the question initially. I kind of like it actually. I just don't like the fact that we have to put an answer with a k in it. So if I was putting this on the test, I would restructure it as so it's a little more clear. All right? But I'm assuming the book wants this answer. I would be really happy with that one. That's plenty difficult. It's hard enough as it is to not have to deal with all the other stuff. So far, so good? Kind of? Not an easy question. Well, I'm doing this without a calculator. A good chance you would have just grabbed a calculator, done inverse tangent of negative 2/3, and then just added pi's or added 180s, whatever you're doing. But hopefully pi's. I'm trying to do this with an exact answer, without a calculator. Let's go on to when is it speeding up? Is that your question next?
Yeah.
Okay. So this is even worse. Because now I got to do this little grid thing that I showed you once before. If you have a velocity function and an acceleration function, what you're going to do to try to figure out when is a particle speeding up or slowing down is you're going to list all the critical numbers for velocity on a number line and all the critical numbers for acceleration on the number line. So what I'm going to try to do is list all those now, which is going to be kind of a pain. If I look at both of these triangles at the same time, I start at 0 degrees and I start rotating up to 90 degrees. You see how I hit this triangle first? That triangle's exact answer right here is inverse tangent 3/2. That's the first really darn important number. This is actually truly critical. So inverse tangent 3/2 is the first thing I care about. As I rotate from 0 degrees and start hitting a triangle, the next one I'm going to hit is over here. This exact answer is not principal inverse tangent. It's principal inverse tangent plus a pi. This is me trying to do exact answering stuff. It's a good review, but it's way too mean for what I'm going to be doing on this current test. This is too mean. I like it because it reviews earlier this year. It is stuff you've seen before, but it's a little mean for the test coming up. The next value I would care about is down there. That's also an inverse tangent of 3/2, but it's not principal inverse tangent. It'd be principal inverse tangent of 3/2 plus a pi. And I'm going to have to keep going on this. I don't want to keep going on this, though, because it's going to be kind of a pain. But the next thing I would care about would be principal inverse tangent of negative 2/3 plus 2 pi. Maybe I'll get that one in there. Principal inverse tangent of negative 2/3 plus 2 pi. And then I'll stop, because I really don't have room anymore. But this list would go off to infinity. Remember how if I did want to put this on the test, it's too mean. But if I did put it on the test, I would go 0 to 2 pi. This would stop. You'd be done. Okay. Now I got to go back and figure out the positives or negatives. I got to figure out if velocity is positive or negative between 0 and whatever the heck number this is. I don't even know what number this is, by the way. How the heck do I find a value to test between these two things? Well, go up and draw a picture of a value to test between those two things. It's between 0 and 90. Well, it's between 0 and this angle. So I need to find a triangle that's between 0 and whatever the heck this angle is. I don't even know what that angle is. I don't have a calculator, but there. If I make this infinitely small, it's not 0, but it works, right? Or if I wanted to be trickier, I could do like something like that. That is a value that's going to definitely promise you between those two spots. If I wanted to kind of gamble, I could do this, give myself a triangle I'm more used to. I'm just not 100% certain it's in the right spot. I think it is, but I really don't know for sure. Whereas this one, I'm guaranteeing it's fine. Let's look at the velocity function you gave me. And then I'm going to move on. But velocity says -2 times the sine of the angle. The one I'm kind of suggesting I use right here, the sine of that's roughly 0. So times -2, who really cares? Plus cosine, where is the heck is the velocity function? I lost it. Oh, here it is. I need to like highlight that. Cosine times 3. Well, cosine of this triangle is +1 times 3 is 3. So I know now officially positive. This is kind of a pain without a calculator. With a calculator, it's so much faster with a calculator. And I think the textbook allows you to use one. But what if you didn't have one? Between 0 and 3/2, if I wanted to talk acceleration, I can draw any triangle I want, pretty much, because it's not going to change too much for acceleration. Acceleration doesn't change until over here. But let's try this point again. I'll try to put in acceleration. Acceleration, right here, says I'm going to do -2 times the cosine. The cosine is 1, so that's going to be -2 minus 3 times sine. Sine is roughly 0. So I'm getting a negative answer. It is slowing down over that interval. I would do the next thing, and next thing, and next thing, and try to figure out when it's speeding up. What's going to happen on the particular problem you're really asking me, the textbook, is you're going to find it's probably speeding up here and here. So you're going to say it's speeding up between principal inverse tangent 3/2, principal inverse tangent of -2/3 plus pi, and then plus k's, pi k, both of those. And that's where this thing really breaks down, gets ugly. There's parts of this question I really like. There's parts of it that are just ridiculously difficult, which is one of the bad things about this textbook, which is why I'm not going to use this textbook for AB anymore, but I definitely will for BC. Here's this, and let's move on. 3.565?
Find an equation of a tangent line to the curve with parametric distribution. X equals 8 times and y equals 6 times cosine theta. The point and
Picture of it, they were looking at stuff. I looked at it and gave it.
Almost done.
Yeah, it's almost done.
Tracing the tangent lines y minus y1 over times or equals m x minus x1. I'm almost done. All I need is the slope now. Slope. Slope, otherwise known as dy dx, is just the derivative of y. No, it's not. Be careful. Watch out for parametrics. Make sure that you know slope really is dy dt over dx dt. So mistake number one sometimes people make on this is they just take the derivative of the y thing. Don't do that. Next mistake people are going to make, of course, is they take a derivative of y and they're going to get 1 times negative sine. Ooh, I almost made a mistake there. And then they go derivative of x is 1 times cosine. And they think they did it right, and of course they didn't. That's totally wrong. Don't do this. Make sure you realize this has a dot right there. It's written in white normally, so it's hard to see. But there's a dot right there as well. You got to remember to use product rule. Slope is the derivative of the first times the second plus the first times the derivative of the second. In the denominator, you're going to do derivative of the first times the second plus the first times the derivative of the second. So watch out or product rules.